Hello, happy campers in Year 12. It's time to do some more integration. Let's get into it. First of all, what we need to be aware of is that we're coming up with a new concept here, and that is we can integrate using shortcuts. Now, for example, if I had this, and I asked you to integrate it, you couldn't actually integrate it unless you expanded the brackets out first, and then you'd end up being able to integrate the terms individually. However, if we use the rule that's written above, it says if you're integrating a bracket with a power above it, providing the bracket is linear, that means that the x doesn't have anything other than a power of 1 above it, providing the bracket is linear and there's a power above it, we have a shortcut. And here is our shortcut. It looks a lot more complicated than what it is. What it's saying is copy the exact same bracket down, increase the power by 1, then divide by the new power, but also don't forget to multiply in the denominator by the derivative of the bracket. And we need to put this plus c on the end as we've done before. So for this example that I've written on the screen, we would rewrite the bracket. My new power would be to the power of 4 over my new power times 1. Now where did the 1 come from? Let's look at the bracket. What's the derivative of x plus 2? Not the integral, the derivative. There's differentiation in amongst the integration. The derivative of x plus 2 is 1. So there's that 1. Now you don't need to write times 1, but you need to be aware of that. Plus c, which means the answer is just x plus 2 to the power of 4 all over 4 plus c. Had I expanded these brackets out and integrated each part individually, I would have ended up with the expansion of this answer here. So let's continue and try some examples. Here's our first example. Check the brackets. Yes, the brackets are linear. There's a bracket with a power above it, so we can use our shortcut technique. We can rewrite the bracket and add 1 to the power. There's the bracket rewritten, and we've added 1 to the power. Now I divide by the new power and also by 1, because the derivative of that bracket is 1. So there's the new power, and there's the derivative of the bracket, and they're always multiplied on the denominator. And then we need to remember plus c. And so there's my answer. Now, had I done this question differently, I could have done it like this. I could look at that bracket there, and I know how to expand it nicely because it's a squared. Smiley face it. So we get x squared. X times 4 is 4x. Double that, I get 8x. 4 times 4 is 16. And when I integrate that, I integrate each term separately. So the integral of x squared is add 1 to the power, divide by the new power, so it's x cubed over 2, plus 8x, add 1 to the power, divide by the new power, 16x plus c, which equals x cubed over 3 plus 4x squared plus 16x plus c. Now, you might look at that and think that answer is different to this one, but if I expand those brackets out and divide everything by 3, that's what I'll end up with. So you can see the shortcut is a much faster technique to get the integral, and it's going to be far more beneficial, especially when powers are bigger than 2. Let's try our next example. We have a bracket that's raised to the power of 3. So the bracket is linear. That's good. No squared or cubes or anything above the x. So we can rewrite the bracket and add 1 to the power. Then we're going to divide by the new power multiplied by, what's the derivative of the bracket? 5. So we divide by the new power. Power is 4, new power, and there's my 5. And then I need my plus c. 4 5s are 20, so I can tidy that up, and there is my integral. Moving on to 1c. It's a little bit more challenging because the bracket has a square root around it. And the moment we see square roots, we know that we cannot integrate or differentiate until we put them into index form or power form. So hopefully you can remember that square root means to the power of a half. So if I was to take something like this, if I said the square root of x, hopefully you remember that means x to the power of a half. When you see a square root sign, it means to the power of a half. If you see a cube root sign, it means to the power of 1/3. If I actually see something like this, that means if I want to convert it to index form, it's x to the power of, now the square root at the front is sitting on the 4, so that's on the bottom, it's x to the power of 5/4. Hopefully you can remember your indices conversions, but to start with they're just going to be square roots, and square roots are to the power of a half. So we can rewrite that question as the integral of t plus 2 to the power of a half instead of writing the square root of t plus 2. Now, it doesn't matter that I'm using t's instead of x's. When I look at that bracket, it's linear. The t doesn't have any powers above it. It's t, or other than a 1. So that's okay. So the shortcut is rewrite the bracket and add 1 to the power. Now what's 1 added to a half? Becomes 1/2. But 1/2 I prefer to write as 3/2. We prefer to write them as improper fractions. So now we're going to divide by the new power as well as the derivative, and the derivative of t is 1. So there's the new power multiplied by 1. Don't forget the plus c. Now there is something we discussed previously, but you may not remember it. If I have something like this, a fraction within a fraction, that's the same as a divided by b over c, which is the same as a times c over b, which is the same as ac over b. Which means effectively the shortcut when you've got a fraction within a fraction is you look for the denominator of the little mini fraction and move that up to the top, and it would become AC over B. So let's apply that. When I look at my fraction here, in the mini fraction within my big fraction, on the bottom of it there's a 2. So the 2 moves up to the top. And so I end up with 2 bracket t plus 2 to the power of 3 on 2 over 3 plus c. Now if you stop there, that's okay, but you can actually take it one step further. If you want to return it back to surd form, you can. It becomes 2 square root t plus 2. The square root comes from over 2 there with the power, and that's raised to the power of 3 all over 3 plus c. So there's the way you can write the answer if you return it back to surd form. Let's look at example 1d. This one's actually much easier. Even though it's fractional, it's much easier than 1c. We look at that question, we're integrating it, so it's just a standard form. We add 1 to the power. 1 plus a quarter is 1 1/4, but we write that as an improper fraction, so it's 5/4. And then we divide by the new power. There are no brackets with this one. Don't forget your plus c. Now, when you look at the fraction within the fraction, the little mini fraction, on the bottom there's a 4. So that moves to the top, and you end up with 4. X to the power of 5 over 4 over 5 plus c. There's your answer. Now the question was written in index form. The answer's written in index form, so we can stop there. We travel over to 1e. We can't integrate when there's a fraction with x's on the top and x's on the bottom. So we've got to do some cancelling, and we notice that every term on the top has x's in it, so we can divide the x squared in to each of the 3 terms. X squared goes into x to the power of 6, x to the power of 4 times, because 6 take away 2 is 4. When I look at the power here, that's a 4 and a 2. 4 take 2 is 2, so x squared goes into x to the power of 4, x squared times. And on the last term, the x squareds will cancel each other out. So that just cancels straight down to that by dividing the x squared into each term. Now it's quite a simple question where we just look at each term individually, add 1 to the power, and divide by the new power. So, when I look at my first term, adding 1 to the power gives me a 5, so it's x to the power of 5 over 5, minus 2x to the power of 3 over 3, plus 3x, and then we don't forget the plus c on the end. And that's the answer. We can stop there. It's now time for you to have some fun. Enjoy!